Hi there, in this video I'm going to explain methods in order to determine an approximate solution for the root of an equation. Okay, so in the previous videos we've seen methods that gives us an idea in terms of how many roots the equation has, but also it gives us an idea of where the root approximately lies. Okay, so one of the methods in order to get an approximate solution for the root is the iterative method. So in this video I'm going to go through the iterative method. So let me title this Iterative Method. So let's get a red pen and a ruler, underline this. So let me explain what I mean by an iterative method. An iterative method so this method is a repetitive method, so it's a repetitive method which generates a sequence of approximations. Okay, so it's a repetitive method that generates a sequence of approximations. Okay, you'll see the method more clearly when I explain the steps involved. Okay, but for now let me explain to you the method. So here's the method behind the iterative process. So let's underline that. Let me explain the method in the form of steps. So in step number one, you'll be given the equation fx equals 0. Okay, and fx is a function of x, so where fx is a function of x. Okay, and for the iterative method you'll be given a starting x value. Okay, so a value that is usually called x0. So x0 is the value that you start from, and this x0 is a value which is so it's an estimate as to where the root is going to lie. So it's just an initial estimate in terms of where this root is going to be lying for the equation fx equals 0 itself. So this value may be given, or you may need to come up with an estimate yourself if you know where this root lies within a set interval. So this value may be given to you. Okay, so given, and in step number 2, so let me underline this. Step number 2 is you take this equation of the form fx equals 0 and you need to rearrange it in the following form. Okay, so let me just say rewrite fx is equal to 0, okay, in the form. So you need to rewrite it in the form so that you have only x on the left hand side, okay, and a function which I'm calling gx on the right hand side. Okay, so once you've done that, once you've rewritten your equation fx equals 0 in the form x only on the left hand side and the function gx on the right hand side, okay, in the last step, step number 3, so let me underline that. Okay, so you replace the x on the left hand side by an xn plus 1. and you replace all of your x terms on the right hand side by xn. So you're going to have gxn. Okay? So once again, replace the x on the left hand side by xn plus 1, replace all of the x's on the right hand side of the function gx by xn. Okay? So remember, x0 will be given to you. Okay? And we call this equation over here xn plus 1 equals gxn. Any formula of this type, we call this an iterative formula. Okay, so this is our iterative formula or iterative equation. Okay, and using our iterative formula and using x0, which will be given, you'll be calculating x1, x2, x3, and so forth and so forth. Okay, and you stop the process until you reach your desired degree of accuracy. Okay, so for example, if the question says work out an approximate value of the roots to, for example, 2 decimal places. Okay, so you stop this process until the consecutive values of x are the same to 2 decimal places. So just as an example, if you worked out x2 and x3, say, and if these values of x are the same to 2 decimal places, the desired degree of accuracy, then you stop the process. Okay, if it's not the same to your desired degree of accuracy, you continue until you have consecutive values of x which are the same to your desired degree of accuracy. Okay, so let me just say that the method is continued until a desired degree of accuracy is reached. Okay, so and this desired degree of accuracy, as I say, that will be given to you. So that should be given in the problem. Okay, so that is the iterative method. So these are the steps involved for the iterative method. Let me take an example. Okay, so in this case, let me follow through. So let me continue over here. So in example number 1, so let's find that red pen and a ruler and underline this. So example number 1 is, now in this question the iterative equation or the iterative formula is given. Okay, so in some problems they may give you the iterative equation or the formula, okay, but in other problems you may need to go through these steps in order to create your iterative equation or formula. Okay, so just in case, here are the steps in order to create your iterative equation or the formula. But in this problem, so here's an example number 1. So we need to use the iterative equation, and the iterative equation is xn plus 1 is equal to e to the power xn, so it's e to the power xn divided by 5 with x0, so x0 is given, x0 is equal to 1, okay, to calculate a root for the equation 5x minus e to the x is equal to 0, correct to 2 decimal places. So let me show you how the process works with this example. So in this question, we need to use the iterative equation. So it's given to us xn plus 1 equals e to the power xn over 5, with x0 equals 1, to calculate a root for the equation 5x minus e to the x is equal to 0, correct to 2 decimal places. Okay, so the first thing for me is understanding the question. Okay, so we need this. This is our iterative equation. Okay, we need x0 equals 1, so we're starting with this value. We're going to be using the iterative equation in order to get a closer approximation for the root for this equation. So we're going to see that shortly. Okay, and we're calculating a root for this equation, 5x minus e to the x equals 0. Okay, now we don't need this, but the iterative equation or the iterative formula, this formula here originates from this equation, and you can come up with this formula using the steps that I explained earlier. Okay, so using these steps, you can start with this equation fx equals 0, and you can create this iterative equation quite easily. Okay, so and we need to calculate this root correct to 2 decimal places. 2 decimal places is our desired degree of accuracy. So remember what is meant by desired degree of accuracy. What we mean by that is we continue the method until the consecutive values of x are the same to our desired degree of accuracy, 2 decimal places. Okay, so we're going to see that right now. So let's make a start. So we have xn plus 1 is equal to e to the power xn divided by 5, and our x0 is 1. Now if I put x0, so if I put x0, which is 1, into our iterative equation, we're going to have xn, which is 0, plus 1. So 0 plus 1 is 1, so that's the value of x1. And that is equal to e to the power x0, okay, divided by 5. So we know x0, that's given, that is 1. So if I replace, I'll have e to the power x0, which is 1, divided by 5. Okay, and when you calculate these values, okay, so my advice is when calculating these values, calculate them to a minimum of 6 decimal places. Okay, so use at least 6 decimal places when you write down the values as a minimum. To a minimum of 6 decimal places, I had 0.543656. So when you write down these values, write down the values to a, so let me use a red pen, minimum of 6 decimal places. Okay, so we're going to use this value, or you can use the whole value of your calculator and put that back into the iterative equation to work out the next x value, which is x2. Okay, so if I put x1 into our iterative equation, we're going to have x1 plus 1, which is x2, and that's equal to e to the power x1 divided by 5. Okay, so as I said, you can use the whole value of your calculator, okay, using the button A and S. So in the Casio calculators, there is a button A and S. So if you use that button, you can apply the whole value of x1 into your iterative equation, or you can use the minimum 6dp answer and replace that back into your iterative equation. Okay, so when I calculated e to the x1 over 5, I had an answer to minimum 6 decimal places of 0.344458. Okay. Now let's check whether they're the same to 2 decimal places. So let's check these consecutive values of x, x1 and x2. So for x2, 0.34 to 2 dp. For x1, 0.54 to 2 dp. They're not the same, so we continue. Okay. So remember, we only stop if the consecutive values are the same to our desired degree of accuracy. So let's continue. If I put x2 back into the iterative equation, we're going to have x2 plus 1, which is x3. That is e to the power x2 divided by 5. Okay. So I calculated this, and to 6 dp minimum, I had 0.282245. Okay, so you can double check that using your calculators. That is the value to 6 dp. Now let's check these two consecutive values, x2 and x3. So to 2 dp over here, 0.34, to 2 dp, x3, 0.28. They're not the same to 2 decimal places, our desired degree of accuracy, so we continue. So if I put x3 back into the iterative equation, x3 plus 1, which is x4, that is e to the power x3 divided by 5. Okay, so I calculated this again, and to 6 decimal places minimum, I had 0.265221. Okay, so let's check these. Let's check this value with the previous. So to 2 dp, x4 0.27, to 2 dp, x3 0.28, not the same, so we continue. Okay, so if I put x4 back into our iterative equation, x4 plus 1, which is x5, that is e to the power x4 divided by 5. I worked out this one, and I had to 6 dp 260, so 0.260744. Okay, so let's check this value of x5 with the previous. So to 2 dp, x5 0.26, to 2 dp, x4 0.27. Not the same, close but no cigar. Let's continue. So if I put x5 back into the iterative equation, x5 plus 1, which is x6. Okay, so in this case, x6 will be e to the power x5 divided by 5. So I hope you can see that. So I calculated this one, x6 to 6 dp, and I had 0.259579. So let's check these two values. To 2 dp, x6 0.26, to 2 dp, x5 0.26 also. So we stop the process. So remember, these two values, these two consecutive values for x5 and x6 are the same to 2 decimal places. So over here, if I take my red pen, 0.26 to 2 dp. Over here, x6, 0.26 to 2 dp. They are the same, so same to 2 decimal places, our desired degree of accuracy, so we stop. Okay, so the approximate solution for the root of this equation, x, will be 0.26 to 2 decimal places. Okay, so that is how the process works. So that is how the iterative equation or the iterative formula works. Okay, and just in case again, just in case, the equation is not given to you, you can form this equation using these steps as I explained earlier. Okay, I'm going to graph y is equal to x. Okay, so the left hand side xn plus 1, so that comes from x from step number 2. So I'm going to graph y is equal to x and y is equal to g of x. Okay, so I'm going to graph y is equal to x, the left hand term, and I'm going to graph y is equal to e to the x plus 5, the right hand term. And let's have a clearer idea of what's happening when it comes to these calculations. So let's get a clear idea in terms of these values and how they relate to the sketch of y equals x and y equals e to the x divided by 5. So I think a screenshot is in order. So looking at his screenshot, so y is equal to x, that line is drawn in blue, okay, and I have y is equal to e to the x over 5, which is drawn in red. So, and I've highlighted the roots that we're looking at. The root is highlighted in green, okay, by a green circle, okay. And if we look at the second screenshot, okay, so here's our green circle. So here's where the root is, okay, the point of intersection of y is equal to x and y is equal to e to the x divided by 5, okay, and our root from this graph lies between 0 and 0.5, but the value that we had is 1, so it's closer to where the root is actually lying, so we're given this value of 1, okay. So remember, 1 is the value of x0. So let's have a look at the next screenshot. And if we put x0 is equal to 1 into our iterative equation, remember we had 0.543, okay, 656, okay. So on this sketch, I wrote down 0.54365, okay, but remember we had a 60p minimum value in our calculations for x1 as 0.543656, okay. Now remember, in our calculations we took x1 and we put that back into our iterative equation. So we use this x1 value, and that is our new value of x, okay. So if we see in the next screenshot, so we've taken that value of 0.543656, that is our new x value, okay, that we put into our iterative equation, and once we substituted it in, we had another value. So let's go to the next screenshot. And that value, remember, in our calculations was 0.34458 to 6 decimal places, okay. And then we've taken this value to be our new x value, okay, in order to work out x3. We had a value of 0.282245 to 6 decimal places minimum, okay. And we continue this process until we reached our desired degree of accuracy of 2 decimal places. But what I'm trying to get across is, by continuing the process, we're getting closer and closer to the point of intersection of these two curves highlighted in green, which shows the root of this equation, 5x minus e to the x is equal to 0, okay. So that gives us a graphical idea in terms of how this iterative process is working, okay. So back to the paper and pen. So that ends this example, and that ends the detailed explanation using some screenshots in order to give you an understanding of how the iterative process works. Okay, and remember, here is the method in order to create your iterative equation if the formula or the equation is not given to you. And that also ends this video. So I hope you found this video helpful. Do related practice questions, and I hope to see you in the next video. Thank you.